All right, so I got to repeat myself. All right, so what gives me a vertical asymptote are values of x that make the function undefined. So what we've been dealing with are rational functions, okay? And so what makes a rational function undefined is when the denominator down here is equal to 0. So values of x that make my denominator 0 are going to be my vertical asymptotes. Now, and we'll see this a little bit better when we do an example. Now, there's an exception to this, okay? And so I probably should put a comma right here and say, all right, except for when linear factors cancel, okay? And this is kind of hard to describe here, okay? So when I get some things that cancel out, even though they still might make the function undefined, they're not going to give me a vertical asymptote, but this is when I would get a hole in the graph, okay? And so when I don't have a, when I get a vertical asymptote, or it looks like a vertical asymptote, but the factors cancel out, it's not a vertical asymptote, but it's a hole. Now that's probably really confusing, okay? I'm sure probably nobody really got that, but just watch here, okay? So let's do an example. And one of the things that we're going to do today, we're going to name the vertical asymptotes and any holes if we got any, but we're also going to start talking about the graph, okay? So, and we're going to bring in our horizontal asymptotes and our slanted asymptotes too, all right? So let me look at an example with you here. Let's try this one. All right, so let's say we got maybe f of x equals x minus 1 over x squared minus 4. Okay, now let's go ahead and start with the stuff that we know, the horizontal asymptotes and slanted asymptotes. Okay, so horizontal asymptotes. Okay, who's winning? Denominator. So that means the horizontal asymptote would be y equals 0. Okay, so if I have a horizontal one, it's going to happen on slanted ones. Yeah, you're not going to have one. Okay, so power of the numerator is not one power higher than the denominator. Now, here's our new stuff. So, vertical asymptote. There again, the vertical asymptote are the values of x that make it undefined. Okay, so here's basically what I have to do to get vertical asymptotes and holes. You have to take your rational function up there and you have to simplify it. Okay, so that means we're going to like try to cancel something out. Now, can I cancel out x with x squared there somehow? No, because the operation has to be multiplication. So what's something here I'm going to need to do to try to simplify this? Factor. You got to factor. Okay, and so this is why I told you to leave some room here on your sheet from last night. Now, you can't factor x minus 1, okay? And not everything's going to factor out for you. But we should realize what? X squared minus 4 would be what? X minus 2 times x plus 2. Okay? Difference of squares. All right? So now, the vertical asymptotes is what's going to make the function undefined. What makes the function undefined is if the denominator is 0. Okay? So now look at my simplified form. So notice when I do these two, I don't need to simplify it, do I? Okay? But when I'm going to look at these two, vertical asymptotes and holes, I need to look at the simplified version. Now, can we actually simplify anything? Can I cancel anything out? No. Okay? So it really didn't work out. But the values that's going to make it undefined here and here would be what? Positive 2 and negative 2. All right? Now, vertical asymptotes, let me kind of go back and add this. You remember horizontal asymptotes was the form y equal a. Slanted asymptotes is y equals mx plus b. Okay? So, right, vertical asymptotes is going to have the form x equal a. Okay? So, we're not just going to say here 2 and negative 2. we'll say x equals, okay? So we get x equals 2 and x equals negative 2. Now, we can say that faster if you want to. It's a faster way to write that, plus or minus 2, okay? And you can write it like that. All right. Now, a hole, again, occurs instead of where we have a vertical asymptote if something cancels out. Now, notice, y'all said it didn't simplify, did it? So nothing cancels out there. But let's pretend just a minute, okay? So if this in the numerator would have been x minus 2, it would have canceled out. So I wouldn't have a vertical asymptote at 2. Instead, you would have a hole at 2. But that didn't happen, did it? Okay, so since nothing really canceled out or simplified, linear factors didn't cancel or simplify, so there are no holes. Okay, in just a little bit, I'll try to do an example where we see a hole in the graph. We got to see one. Now, what I want us to do from here now, and what I want you to do tonight, you've already done that part, right? On all those problems. So you have to do the vertical asymptotes and the holes, and I want you to go ahead and graph. Okay, start the graph. So we're not going to graph the function. We're just going to graph any asymptotes or holes. So let me get me a graph here. Give me a graph. All right. So to get my graph, let me copy that. All right. The graph asymptotes, all you do is just draw dotted lines. Okay. So a horizontal asymptote of y equals 0 would look like this. This would be a horizontal line that would basically be the x-axis. All right. And now we've got vertical asymptotes at 2 and negative 2. So those are what, did I say horizontal? I said vertical. Okay. So vertical asymptotes there at positive 2. So you do a dotted line at positive 2 and then a dotted line at negative 2. Okay. Right. Now we'll fill in the curves probably like on Thursday. Okay. All right, so let's look at this one now. So we got x squared minus 9 in my numerator, and in my denominator, I'm going to do x squared minus 3x. Okay, now this time I think we're going to get to see what a hole in the graph looks like. Okay, so let's start off with the stuff that we know. Okay, the horizontal asymptotes, if any, not vertical, but slanted asymptotes, and then we'll go to our new stuff, vertical asymptotes, and we're going to have a hole on this one. All right, so horizontal asymptotes. Let's see who's winning. It's a tie. Okay, so ratio of leading coefficients 1 to 1 would be 1. So horizontal asymptote would be y equals 1. All right, so I'm not going to have a slanted one then, am I? Okay, so no slanted one. All right, vertical asymptotes. So before I even start deciding what they are, what do I need to take my function to do? Yeah, you need to try to simplify the function. Okay, so simplifying or canceling out means you're basically going to have to do what really? Factor. Okay, so let's factor the numerator here. This would be x plus 3 times x minus 3. And then in my denominator, I could factor out an x, right? So it'd be x times x minus 3. Okay, right. Now those x minus 3's would cancel out. Okay, so I have basically x plus 3 over x. Okay, now, so let's start with vertical asymptotes. Vertical asymptotes is what makes the denominator 0, or what makes the function undefined. Okay, so you would have what makes that 0 would be 0. Okay, So we have a vertical one at x equal 0. And we got to say x equals because it's the equation of a vertical line. All right. Now, what about this? So what about 3? Would I have a vertical asymptote at 3? No. Even though 3 would make it undefined, what happened is the x minus 3 canceled out. So instead of a vertical asymptote at 3, you would have a hole at 3. Okay? All right, does that make sense? Because the x minus 3's canceled out. So when they cancel out, that's what's going to give me a hole. Okay? All right, so here's the thing. A hole is a point. Okay? And 3 is the x coordinate only. All right, so a hole is going to look like, it's going to have the format x comma y. So it's going to be 3 comma something. Now, what I have to do though is find out what the y coordinate is. It's not 0. Okay, so let's see if you can figure out. Now, are y'all with me so far?
Where did you get x equals 3 from the x minus 3?
Right, and saying what makes it undefined. So x being 3 would make it undefined. So we normally say what makes it undefined are my vertical asymptotes, except for if it cancels out. And so since it canceled out, I'm not going to have a vertical asymptote at 3. I'm going to have a hole at 3. Now, the way you find the y coordinate, that's where we're at. How do you think we would find the y coordinate? This is the x coordinate, right? Yeah, just plug it in. Now, where would we plug it in at, though? The last one. Because in the original equation, it's going to be undefined. Okay? So when you plug in the 3 to find the y coordinate, you plug into the simplified form, the most simple form. Okay? And that would be this one over here then, right? All right. So if we plugged in 3, we would get 3 plus 3 over 3. Right? So that would be 6 over 3, which would be 2. And so that would be my y coordinate. Okay, so now I have a horizontal asymptote at 1, a vertical asymptote at 0, and a hole in the graph at 3 comma 2. Okay? Right. When right. So if that x minus 3 wouldn't have canceled out, we would have had a vertical asymptote. Okay? Now, let's look at the graph of this. Okay. Now, y'all help me graph all this stuff. So how do we do a horizontal asymptote at y equal 1? All right. Right, at 1, right? So it's horizontal. Yeah. All right. So write a vertical when x equals 0. So that would actually be on top of the y-axis. Okay. So look like that. Now, how do we do a hole? So 3 comma 2. And so how do we show something that doesn't, it's not actually there, but there's a hole there? Right, open circle. Okay. So at 3 comma 2, we're going to have an open circle right there. So we don't know what the curves look like. Okay, I can imagine here the curves are going to look something like this, and we're going to talk about that tomorrow. But when the curve gets to that point, it kind of jumps over that. You remember how we did that, the holes in the piecewise function? So the graph actually jumps over that particular point. Now, there again, that's more for tomorrow, and really what's going to fill in the rest of the graph is going to be your graphing calculator. Okay, so the idea is that you're going to graph all the holes in the asymptotes, and the calculator is going to graph the curves for you. Okay, so it's kind of like a half-half thing. You do half of it, your graphing calculator will do the other half. Okay, all right, questions about this one so far? Yes, sir. What now? All right, for the homework, graph the asymptotes and the holes. Okay, but that's it. tomorrow what we'll come in and do is we'll fill them in. All right. Now, let's look. Let me do another one here. This time, let's do one with a slanted one maybe. All right, let's try this one. All right, let's try this one. Okay, so we're going to start off, and let's kind of talk about why do we want to start off with the horizontal ones or possibly the slanted ones? Yeah, they are. Okay, so to find verticals and holes, you have to simplify, don't you? All right, but horizontal asymptotes and slanted asymptotes, you don't have to do anything to the function. You just look at it. So what about any horizontal ones? Are we going to have any? No, you don't have any, so none. Okay. Right, we're all going to have a slanted one, so we're going to have to do division, synthetic division. Okay, so be 1, 3, -4. So that'd be -2. 3 minus 2 is 1. -2 to 1 is -2. And that doesn't matter anyway. Okay, so my slanted one here would be y equals x plus 1. Okay, and we're going to graph that in a minute. Now, bless you. Let's talk about the vertical ones and possibly any holes. All right. Now, all right. So what are we going to have to do to figure out vertical ones? Can we just say -2 because that's what's going to make it undefined? Mm-mm. We need to simplify it first, right? Because there's a possibility that that x plus 2 might cancel out. Okay, so we really can't factor the denominator, but we could do the numerator, couldn't we? All right. So what factors of 4 that subtract to be 3 would be 4 and 1. It would be x plus 4 times x minus 1. So is it going to simplify for me? No, this one doesn't simplify. Okay, so there's not going to be any holes. Because it doesn't simplify, no linear factors cancel out. Okay, so no holes. Now, so vertical asymptote, we're going to have one at x equal -2. Okay, so where's this value coming from? That's what makes it undefined. What makes the denominator 0. Okay, now let's sketch the graph here. And when we say again sketch the graph, we're not really doing the graph. We're only doing the asymptotes. All right, so this time we've got a slanted one. Now, we better know how to graph y equal x plus 1. Okay, yeah, it's just a line. What, it's got a y-intercept of 1, and I would think of the slope as being 1 over 1. Okay, so we're at what? 1, and then rise 1, run 1. Okay, and now it's not a solid line, it's a dotted line because it's not actually a part of the graph, it's just a line that I'm going to chase here. One thing I like about the smartboard, I can't throw a ruler on there and drop real straight. I guess I could do this. Oh yeah. There we go. That's a pretty one right there. Now, all right, there's my slanted one. Now we're going to have what, a vertical one at -2. Okay, so we're going to do this. And now tomorrow we'll go in and fill in the curve. Okay, all right, that's what it's going to look like, right? I have a slanted one and a vertical one. All right, let's do another example. I'm going to make this one up. Let's say we got f of x here equals x squared plus 3x minus 4. Almost the same thing as I had last time. I think it was the same thing. All right, and on the bottom part here, let's do x squared plus 5x minus 6. Okay. All right. So let's see. Horizontal. All right. Slanted. All right. So horizontal would be y equals 1. All right. Who's winning the race? It's a tie. The ratio of leading coefficients would be 1 over 1. All right. So slanted, none, because the power of the numerator is not one higher than the denominator. Now, vertical asymptotes and wholes, we need to simplify. Okay? So to simplify, we're going to factor and see if anything happens to cancel out. So factors of 4 that subtract to be 3 would be 4 and 1. Okay? So it'd be x plus 4 times x minus 1. And then factors of 6 that subtract to be 5 would be 6 and 1. So it'd be x plus 6 times x minus 1. So would it simplify then? Yeah, x minus 1s cancel out. So we're going to have x plus 4 over x plus 6. Okay, so let's talk about the vertical asymptotes. The vertical asymptotes is where it's undefined except for when it cancels out. Okay, so we're undefined at -6, so we'll have a vertical asymptote at x equal -6. Now, at x equals 1, this is not right. It cancels out, right? So instead of a vertical asymptote, it would be a hole. Okay, so it's going to be 1 comma something. Yes, sir. What? From right there. So what makes it undefined? So the hole is basically going to be what makes it 0 if it canceled out. Okay. Now, how do we find, and notice what holes is not an equation, are they? They're just an ordered pair. Okay. So how do we find the y coordinate? All right. Do what with it now? Yeah, plug it in. Now, so we're going to plug it in what? Here? No, the simplest one. Okay, so that would be, and that's actually works out a lot better because it's easier to plug in into the simplest one. So if we plug in 1, we get what? 5 over 7. Okay, so the y coordinate would be 5/7. Okay, yeah. So a lot of times the holes, especially the y coordinates, they don't turn out too well. Okay, so 5/7. That's just what? A little bit past halfway. Okay, a little bit more than a half. Now, let's put our graph on here. All right, so let's see. Horizontal asymptote at y equal 1. All right, no slanted ones. Vertical asymptote at x equal -6. And now we have a hole at 1 comma 5/7. Okay, so go 1. Now 5/7 would just be under 1, wouldn't it? Okay, so there's 1. And so 5/7, right. So here's the thing. It definitely would not be on the asymptote, would it? Because we can't touch asymptotes, all right? So it'd be like right there. Somewhere in there is going to be a hole, okay? All right. Now, we can try one now. We can try them off the homework, okay? Now, the thing about the homework is you've already done this, haven't you? Okay? So we've already done half of it. So now, what you're going to have to do is you're going to have to go in, find the vertical asymptotes and holes, and then put all the asymptotes and the holes on the graph. Okay, so we're not actually graphing the function, just the asymptotes and any possible holes.